Hello everyone, this is Wilson. Today I'm going to talk about this derivative problem here. We have a product of two factors, and one of them is 3x minus 2 raised to the 1/3 power, and the other one is x plus 2 raised to the 2/3 power. And so now the question is, how do we take the derivative of this function? Because this is a product, so we are going to be using the product rule, but at the same time, you can see that there is an inner function that's inside the outer function, which is the 1/3 power. And then same thing right here. There was the inner function of x plus 2, and then there was this outer function of um, the power function, right? There was this expression raised to the 2/3 power. And so what happens is that we got to use the product rule, the power rule, and then also the chain rule at the same time. Okay, so you can think of it this way. The big picture is the product rule, but then we got to use chain rule and general power rule along the way. Okay, so let's get started for finding the derivative. So first, for the product rule, we are going to just recall it here so that we can apply it more easily. We have f times g, right? So let's say you have two functions multiplied together. Then what happens is that you are going to be getting f prime g. Okay, so you take the derivative of the first function and then you do not touch the second function. And then for the second term here, you copy down the first function and you do not, so we do not touch the first function, and then we are going to take the derivative of the second function. Okay, so what we are going to do right now is that we are going to first start applying the product rule. So we have f prime of x. Okay, so you can see that this is the first function and then this one is the second one, right? So let me just highlight that. I think that will be easier. So this is the first function, and then there is the other one. The other one is this. This one is the second function, as you can see here. So what we are going to do is that we are going to take the derivative of this, and then we are just going to copy the second function. Okay, so if we take the derivative of this function, we are going to be getting 1/3. Now we gotta apply the general power rule and the chain rule. Okay, so we bring this power to the front, and then we are going to copy down the inner function. That's really just the same thing as substituting the inner function in there. And then based on the power rule, we need to subtract 1 from this 1/3. So 1/3 minus 1 is -2/3. Okay, but that's not finished yet. We actually need to multiply by the derivative of the inside, right? The derivative of the 3x minus 2 is just 3, so I'm just going to get a 3 here. And then what about this second function here? We are just going to copy it down. So let's just copy that down right here. So do not touch that second function, so just copy it. Okay, so that's our first term. And then now plus, right? We put the plus right here, and then we are going to take the derivative of the second term. We are going to take the derivative of the second factor, and then we do not touch the first factor. So I'm just going to copy this. And when I copy, I'm just getting 3x minus 2 to the 1/3. And then now we need to take the derivative of this x plus 2 raised to the 2/3 power. Okay, so what is that? That's going to be bringing down the power to the front. We are going to be getting 2/3 and then x plus 2. Okay, and then now subtract 1 from this 2/3, right? So we are going to be getting -1/3. And then now we need to multiply by the derivative of the inner function. The derivative of this x plus 2 is just 1, so I'm just going to get the 1 here. And then we are done taking the derivative. Yeah, so basically the problem is finished. But if we want to simplify this, then we need to do a little bit more work. So how do we simplify this? Let's just clean up the answer first. So what I'm going to do right now is to just do some canceling here. As you can see, we can cancel the 1/3 and the 3 because this is all multiplication. So I'm just cancel that. Right? And then, so let's rewrite the expression. So it's going to look like what? It's going to look like this. We have 3x minus 2 raised to the -2/3. And then the other factor is x plus 2 raised to the 2 over 3. And then now what about the second term right here? I'm just going to bring the constant to the front. And then we are just multiplying by 1, right? So we don't need to worry about this 1 anymore. So we are going to be getting 2 over 3. And then 3x minus 2, 1 over 3. And then we have x plus 2 raised to the negative 1 over 3. So see what's going on here? Um, so now we clean up the answer. But that's not really the nicest form for finding critical numbers. Let's say if we want to find critical numbers for this function, how do we do it? We can factor. How do we factor? We can try to take out the greatest common factor from both terms, right? So how do we do it? As you can see here, we had 3x minus 2 factor raised to some power, and then there is another one that's 3x minus 2 raised to some power. And so that can be a common factor. But what is the greatest common factor that we can factor out? In general, let me just remind you regarding the greatest common factor right here, like how we handle that kind of situation. For example, okay, so let's just review some stuff right here. Let's just some review. Okay, so what happens is that let's say we have a to the capital A to the third power plus a to the fifth power. How do we factor this? We can actually factor it as a cube. The reason for why we can factor out the a cube is because we want to factor as many copies of the a as possible. So if you want to factor out the same amount, same number of copies for the A, then what happened is that we can only factor out as many as 3 because if you go higher than 3, then there is not enough copies of the A for you to factor out. So we are getting A square. How do you know that we are getting A square here? No, actually, we are not getting A square here yet. We are getting just 1 and then plus the A square. How do we know that we are getting a 1 here? Because if you try to distribute this a cube back to the terms inside the parentheses, then you are getting a cube times 1, that's a cube, and then a cube times a squared, that will give us a to the fifth. Is that okay? So that's how that works. Now, this idea can be applied to factoring this kind of expression. What we need to do here is that we want to take out as much as possible in this case, but at the same time, we have to take out the same amount from both terms. Okay, so that means we need to look at the powers and we want the smaller of the two, and we use that as the exponent for the greatest common factor. So now if we look at the 3x minus 2 factor, the exponent is negative 2 over 3. And for this one, the exponent is 1 over 3. And if we want the smaller of the two, like this one right here, then we actually want to factor out 3x minus 2 to the negative 2 over 3. Okay, so what are we doing here? We are going to factor out the greatest common factor, which is 3x minus 2 raised to the negative 2 over 3. So we factor out as much as the smaller of the two factors. Same thing here for the x plus 2. Which one is smaller, the 2/3 or the negative 1 over 3? The negative 1 over 3 is smaller. So we are going to factor this, which will give me another factor, and that's x plus 2 raised to the negative 1 over 3. So now we still need to fill inside whatever that's left inside the parentheses, right? We still need to fill in this part right here. How do we fill in that part? The idea is actually simple. What we can do is that see how we got the a square here. We just take the original exponent, subtract the exponent of the factor that you factor out, and then you are going to be getting what's left. Okay, so we get to subtract. So now I factor out the same amount, right? So we're actually just getting 1, right, for this factor here. And then what about this one? We factor out negative 1/3. So what we are getting is that we are going to be getting x plus 2, and then I'm going to use the original exponent. And then I want to subtract this exponent that I factor out. right? 5 minus 3 will give us the 2. And then now I want to take this one, which is the original exponent, and I subtract the exponent of the greatest common factor. Okay, so we are going to be getting like the 1 over 3, right? I'm just copying this exponent here, and then that will be whatever that's left for the first term. And then now continue with the second term here. We didn't do anything to the 2 over 3, so I'm just going to put that in the front. Okay, and then so for the 3x minus 2, I'm going to use the original power. Okay, so original power, and then we get a minus what? Minus the exponent of the factor that we factor out as the greatest common factor. So I'm going to subtract this number, which will give me negative 2 over 3. Okay. And then you may say, what about the x plus 2? We factor out just exactly that factor. So it will become a 1 here. And then now we can continue to clean up the answer right here. So if we do that, then we are going to be getting 3x minus 2 to the negative 2 over 3. And then x plus 2, negative 1 over 3. And then now the stuff inside the brackets. 2 over 3 minus negative 1 over 3 is just 1, right? So we are getting x plus 2 right here. And then plus, now 2 over 3. And then same thing here, 1 over 3 minus negative 2 over 3. That's also 1. So we are getting 3x minus 2. Almost done. Almost done. So we are going to be getting 3x minus 2 to the negative 2 over 3. X plus 2 to the negative 1 over 3. And then if we simplify this, then we are going to be getting 3x. And then we have the then we have what? Negative 4 over 3. 2 minus negative 4 over 3. No, 2 minus 4 over 3, which is 2 over 3. Right? Because that would be 6 over 3 here over 4 over 3. And then we are getting 2 over 3. And that's it for the answer. Okay, so this form makes it a lot easier for us to find the critical numbers for this function. Okay, so that's it for this problem. If you like this video, please give me a like, subscribe to my channel, and share my videos to others. It will give me support to make more videos. If you have questions or have a topic that you want me to talk about, please leave me a comment. Thank you for watching this video. I will see you next time.